Here we go. So, this unit, okay, is all about statistics, probability and statistics, okay, which in my opinion is really not algebra, okay. However, the state of Missouri disagrees with me, and we do actually have several Algebra 2 standards in this unit that we will cover. So, jumping right in, what is probability? So, probability is the likelihood of something happening in the future, okay. Probability, we notate it with P of X, and it's always between 0 and 1. If I were to convert 0 and 1 into percentages by moving that decimal, okay, obviously it doesn't affect the 0, but everything would be between 0 and 100%, which makes sense, right? Okay, there's not a 101% chance that it can rain on any certain day, nor is there a negative percent chance that anything could happen either. Okay, anything that's going to happen is there's going to be a 0 to 100% chance of it occurring. Okay, so probability is the likelihood of future events, but statistics is actually analyzing things that have already happened, okay, data points that we already have. So I'd probably just underline analyzing numerical data. It can be in large quantities. We could do data from a sample, which we'll typically see, okay, but this is using data that we already have. Okay. Population and sample. So a population is the whole group, okay? So the population of the United States, that's everybody that lives in the United States, okay? Then we have samples, which are smaller parts, okay? So we have a big election coming up this November, right? Okay? It would be physically impossible for me to poll everybody in the United States to see who they're going to vote for, okay? However, I could take a sample, so I could take a smaller group of people and send a poll to them, okay? And hope that that would be representative of the whole. Okay, does that make sense? Population versus sample. Population is big, sample is smaller. Okay, so we'll talk about that a little more later on in this unit as well. And then we have 4 different types of graphs. There's obviously thousands of types of graphs in the world, but there's 4 that we're going to zone in on today. Okay, the first one is called a histogram. So this is just a type of bar graph. Okay. Bar graphs were probably one of the first graphs you ever learned in elementary school, okay? This was back when math was like really, really fun, right? Before our teachers made us cry. Your teacher probably did some kind of experiment. Raise your hand if your favorite candy is Skittles. Raise your hand if your favorite candy is M&Ms, right? And then everybody in the class like grouped up. We made bars for each group, okay, depending on what candy you liked. And then you all ate candy together, and it was just a really good day, okay? However, we're not going to do that in this math class, but we get the picture of what bar graphs look like, okay? This specific type of bar graph, though, is a little different. So one thing that's easy to point out with the histogram is that the bars have no gaps between them, meaning that they're all smushed together, they're touching, okay? But these are going to have quantitative data on both the x and y axis. And the y-axis is always going to be your frequency, okay? So it's kind of just a frequency graph. And we will do one of those today. Okay, we also have dot plots. So these are literally exactly what they sound like. It's just a plot of dots, okay, representing data. Each dot represents one value in a data set. So the amount of dots should be the amount of the amount of dots should be the total amount of data points that you have, okay? Then we have a stem and leaf plot. You've also seen this before, okay? The last digit is always going to be the leaf. The stem will be all the other digits before it. And then pie charts, you know what pie charts are, okay? So all of these we've probably seen before, whether we've made them or not, I don't know, but we're going to make them today. So we've got 39 players in the Kansas City Chiefs, okay, and we have all of their weights here, okay. For this first data set, they're all rounded up to the nearest 5 pounds, okay. So we are creating a dot plot. How we do this, when you go to create your own today, okay, you'll actually have to make your own scale, okay. If you look here at my scale, I go from 150 to 400. Where do you think I got those numbers? How do you think I knew where to start and where to end? Yeah, I look at my actual data, right, Tristan? So what am I looking for in the data? Lowest and the highest number. You got it. Okay, so if I look, it looks like my lowest number is 180. My highest number, I believe, is like 360 something, 365, okay? So to encompass that, to make sure I have my lowest number to my highest number, I started at 150 and I ended at 400, okay? Notice how I'm going up in even increments. So I'm going up by what? 25, okay? Every single time. This whole thing is even, okay? It's an even number line, okay? That is a requirement for a dot plot. So make sure that your scale has your lowest to highest number at least, and everything in between, and then make sure that you have increments that are even, okay, on your number line. So how this works now is literally 39 players that have all their weights. I need 39 dots on this thing. So for instance, the first weight is 315. So I'm going to go to where 315 is, or just about where I think it is, right about here. Put a dot, cross that weight off, and then keep going, okay? I'm going to do this for every single point. One thing I want you to pay attention to though, okay? For instance, this 210 right here, if I notice, there is 1, 2, 3, 4 210s, okay? So where 210 is, I need 4 dots stacked right on top of each other. Okay, so we do have to account for repeats, and we just stack those dots on top of each other if we have a repeating digit, okay? So I'm gonna give you a couple minutes. I want you to go make your dot plot. Okay, so this is about what it should look like when you're done. Okay, if you're not done, you can come back to it. But this is what our dot plot looks like, okay? Then the other thing is just, can you answer questions from a dot plot? So especially if you're a sophomore who's going to be taking that EOC for me, or maybe you're even a junior who's going to be taking that ACT in a couple weeks, okay? Sometimes you'll see these on there, okay? So if I looked at this dot plot and I asked you, what is the most common weight for an NFL player? What would it be? Okay, 240. Perfect. Okay, that's my highest stack of dots, right? Okay. So just know how to answer questions. Just know what those dots mean, okay? That the stacked on top of each other dots are just repeat data points, okay? Any questions there? We're good? Okay. Moving right along. Next up, we have the same weights. This time they're not rounded, but we're going to make a stem and leaf plot, okay? So here's the deal with stem and leaf plots. We go to the data and we look at it, okay? Our last digit of the data point every single time is going to be the leaf, okay? And everything that comes before it is going to be the stem. So for this first digit, 315, the 5 is the leaf, the 31 is the stem, okay? It's the same thing going down for all of them. So the next number, the 0 would be the leaf, and the 24 would be the stem. The 2 would be the leaf, the 18 would be the stem, okay? So once again, you got to build your own today, but I built the bones of this for you. How do you think I knew to start with the stem 18 and to end with 36? You got it, the least and the greatest number. So if I go to my data, my least greatest number, or my least amount of I can't talk today. My least number is 180, and my highest number, I believe, is 363. Okay, so that tells me right there I need to go from stem 18 to stem 36. Okay, are you with me? So how I do this then is I just go, now that I have the stems down, I go put the leaves in. So my first digit was 315. I go to stem 31, and I put a 5. Cross it off. Okay, I go to stem 24 and I put a 0, and then I cross it off, and then I just keep going. Okay, so I want you to go through this, finish this up. Okay, so when I'm doing this, what should my amount of leaves add up to? How many leaves should I have? 39, because that's my total. Okay, so that's another way to double check yourself at the end to make sure you didn't leave any of them off. Okay, there's two things now that this has to have to not be counted wrong. Okay, so the first thing is if I go look, all of the leaves need to be in numerical order. Okay, so if I look on stem 18, okay, I can see that obviously these leaves are not in numerical order. Okay, if you use pen, you're more than welcome to just cross these off and then just go put them in order to the side, or even if you use pencil and you want to do that today. Obviously, if this was professional, I would make sure my final copy looked good. You're more than welcome to erase it if you use pencil too, but just make sure that those leaves on your final answer are in numerical order. Are we good with that? Yes? And don't leave out any repeats, okay? Okay, so that's the first thing we need to make sure that this is not counted wrong. Okay, the second thing that we need for this, okay, and again, you have to have this or I'm going to give you a 0 for this graph even if everything else is perfect. You've got to have a key, okay? So I'd probably write that up here, must have a key. It's got to have a key, okay? So how do I make a key? It's so simple. You can literally pick any data point that you have. Okay, it does not matter which one. I'm just going to pick the very first data point that we used, which was 315. Okay, so how I'm going to do this is I'm going to put 31 is the stem, 5 is the leaf. This equals the number 315. Okay, that shows me right there, how do I read this? Okay, how do I read this stem and leaf plot? How do I read each of those data points? Okay, and that tells me. And you're probably wondering, why is this important? Okay, so I'm going to tell you. Let's say, for instance, instead of these data points, okay, let's say I was dealing with something else, like for instance, average rainfall somewhere, okay? So these are my data points that I'm going to make up here. Okay, so let's say that I was making a stem and leaf plot for that. Okay, I would obviously put the stems in order and then put the leaves. In this case, what are the leaves? It's always the last digit. So in this case, it's everything after the decimal point, right? Okay, those would be the leaves here. Okay, so the reason why the key is so important is because, for instance, on this one, 21 is the stem, 7 is the leaf. That stands for 21.7. It doesn't stand for 217 like it did over here with these data points. Okay, so you can see why that key is important because it tells me how to read the data. Okay, does that make sense? Make sure we do that. Okay, once again, you could pick any point, it doesn't matter, but you need to do it like that. Okay, you need to put the stem, put the leaf of that point, and then tell me what it equals. That's all you need for your key. Okay. Henry, you got a question? Nope. Good. Logan, you good? Okay. Girls, you good? All right. Ready to move on? Okay. So for your quiz that you take over this lesson, okay, there will only be a dot plot and a stem and leaf plot. Okay, these next two, the histogram and pie graph, will not be on there. But once again, we're still going to do them because they're important. You might see them on the EOC. You might see them on the ACT. I think histogram is actually a really popular one for the science ACT. So we just need to make sure we know what they mean. Okay, so I honestly did the hard part for you here. Okay, so for the x-axis on this thing, which is weights, okay, we're using the same data. I went ahead and grouped those for you. Okay, so typically when we do that, we would divide our range by the amount of groups that we're going to have, and then that would give us what those intervals are. Okay, but once again, I did that for you, so you don't have to worry about that. Okay, what we do need to figure out though is the frequency. So histograms are built with frequency tables. What do I mean when I say frequency? Just how often does it occur? Okay, so the weight category 150 to 199, how many players fall in that category? Okay, how many players have that weight? So if I go up here, I'm using this same data. You can count your leaves, okay, or you could just go through these points if you didn't mark them off as crazy as I did, and just count how many players fall between 150 and 199. Go figure that out. How many is it? 6. Perfect. You can put 6 tallies or just put the number 6. I don't care. Okay, go finish this now. Okay, go figure out how many are in each of those categories. Okay, what do we get for 200 to 249? 20. And then 250 to 299? 9. And then did you get 3 and then 1? Okay, perfect. Okay. What should that Y column, what should all those numbers add to? 39, my total. Okay, and do they? Yep, okay, so that's just another way to double check that I didn't leave anybody off. Okay, so now we're ready to make this histogram. Okay, it's going to have an X and a Y axis. Okay, if I was making this professionally, I'd probably use a ruler and make this thing perfect. Okay, but I'm just going to sketch it for now. I am going to label my axes because that is a requirement. We always need to do that when we build these kind of graphs. Okay, and then once again, what separates this from a traditional bar graph is that this x-axis is numbers, okay? It's numerical data. So if I look, I need to go from what to what for my x-axis, for my weights? 150. Yeah, 150 to 399, okay? So you can start at 0 and go up by 50s, okay? We do need to go up by 50s just because that's what we do in these increments, okay? Or one thing that we can do when we're building these tables, if we don't want to make this graph huge, okay, because I don't want to waste a bunch of space, I can put this little squiggly line, and then I could just go ahead and start where I want to start, okay? So 150, 200, 250, 300, 350, and 400. Have we seen that before? Just lets you jump ahead. Okay, you don't have to make your graph quite as big. Okay, and then the y-axis. What do I need to go from on the y-axis? 1 to 20. Okay, so the squiggly is probably not really necessary if I've got to start at 1. What should I go up by? Does it matter? You kind of got options here, don't you? Okay, you just need to make sure you have 1 to 20, okay? I'm probably just going to go up by 5s because I don't want to make this thing crazy. But once again, you could have went up by 1s, you could have went up by 2s or even 10s if you wanted to. It's totally up to you as long as it makes sense and it's correct. Okay? And then we go ahead and we make these bars. So just make sure that they have no gaps between them. So this first bar from 150 to 199, I just need to go up 6. And then 200 to 249, go all the way to 20. Oops. Once again, I'd use a ruler if this was like going on a poster or something, but we are just sketching for now. Beautiful. Okay, and then this is missing one thing. Does anybody think they know what it is? What's it missing? Yeah, it's missing a title. What should we call it? Well, like, what is it showing us? What's the graph telling us? The weights of what players? Just any football player? Yeah, weights of Kansas City Chiefs players. Let's just call it that. Okay. So this is just one NFL team, right? And honestly, this data is probably not accurate because we've had these same notes for a couple years now, okay? But this is one NFL team. Do you think that this would be a good sample to use to make predictions about the whole NFL? Could I make the prediction that most NFL players probably weigh what? Between 200 to 250? Yeah, okay. I think that that would probably be a good estimation, okay? Do you think that this would be a good sample to use to maybe predict like high school football players' weights? Like Troy Buchanan high school football team, do you think most of them weigh between 200 and 250? Maybe, but this is probably not a good sample to use for that, okay? So we'll get into a little bit of bias is what we call some of that, so we'll get into that later this unit. But just know that not every sample is representative of every population, okay? It's got to make sense. So we'll keep rocking and rolling through this, okay? Last thing we got is a pie chart, okay? Again, we're just going to sketch this because I don't want to take forever on this. First thing we got to do, though, is we've got to figure out the percentages that these have, okay? So we're going to use the same numbers that we had on the last page. How would I turn those into percents, though? Divide by 39. Yeah, you got to divide by the total. Okay, when I plug those in my calculator, it's going to give me decimals, but I want percents, so just make sure you move that decimal place over too. This is going to be what? Point, can we round it? 3. Okay. Keep going, 20 divided by 39. 51.3. Bless you. 23.1. 7?
Yeah.
Okay. And last but not least, 2.6. Perfect. Okay. What should all of those percentages add up to? 100 or just about. Okay. You might have a little bit of rounding error, so you might be off. You might be like 99 or 101, and that's not a huge deal. Okay. But make sure that they add up to about 100. And then if I were to make this thing perfect, so if I had all day to get out compasses and teach you guys how to draw perfect circles, and then get out protractors and teach us how to draw straight lines with perfect angles, which would take way too long, what I would do from this point is I would multiply all of these percentages by how many degrees are in a circle, which is how many? 360. Okay, so I would multiply 15.3% times 360, which would give me roughly 55.4, I think, something along those lines, okay? And then I keep going down the line. I do that for all of these, okay? But once again, we are in a time crunch, okay? We don't have time for all of that, okay? So what I'm going to do instead is I'm just going to make a sketch with my percentages, okay? It's not going to be 100% accurate, but we're going to get the picture of it, okay? So I'm going to draw my beautiful perfect circle. There it is, okay? I should be an art teacher, don't you think? Thank you. It might be more fun, but I don't know. Maybe not. Okay, my biggest piece is 51.3%, which is just about half. So once again, we're just sketching here. Got a 23.1%, which is almost a fourth. $15.3. Okay, once again, this is definitely not perfect, but we get the picture. Okay, and then it's missing one thing, and what is that thing? Title, what should we call it? That works, weights of Kansas City Chiefs players. That's what it is. It's the same thing. All right, so once again, dot plot, stem and leaf plot, that's what's on your quiz today. Histogram, pie graph is not, but we still need to know how to read them, okay? So just make sure, like if you saw a pie graph on your ACT or your EOC, that you would know that that is pieces of the whole, okay? And that's how we read that. Any questions on this graph or any of the graphs that we just talked about? No? We're good? We're all golden? You promise? Okay. Last thing we're going to talk about today are just a couple different types of distribution. Okay, when I say distribution, it just means how is the data distributed, or how does it look on the graph? Okay, how is it arranged on the graph? So, the first type of distribution we're going to talk about is symmetric. Okay, we've talked about the word symmetric for a long time now. What does it mean? What does symmetric mean? Yeah, both sides are the same, okay? If I folded it up the middle, okay, they would both be the same or approximately the same on these, okay? Sometimes they might not be 100% the same, but they're almost the same. So if I look at this one, we can see that that indeed is symmetric. You with me? Okay, the next one is also symmetric, but it's in the shape of a bell curve, okay? So if I look at this thing, it kind of looks like the shape of a bell, like those Reese's bells that you get at Christmas time that are so good. You know what I'm talking about? The bell-shaped ones, okay? So think of that, okay? So it's in that shape. Symmetric and not bell-shaped, symmetric and bell-shaped. Symmetric and not bell-shaped, symmetric and bell-shaped. Are we good between the differences? Yes? Okay. We also call bell-shaped a normal curve. We're going to talk about that more on day 5. But for now, you can know it as just bell-shaped, okay? Next two are skewed left and skewed right. You are literally just looking at the tail of the data, okay? So if we look at this one, the tail is leading to the left, so it's skewed left, okay? On this one, the tail is leading to the right, so it's skewed right. Are we good with that? Okay. And then the last two. First one is bimodal, okay? What does the prefix bi mean? It means two, okay? And then we have this word in the middle that means mode, okay? You talked about mean, median, and mode. Mean was average, median was middle. Mode is, yeah, most common, the most, okay? So what this means essentially is that there are two most, or two high points, okay? Two high data points. So if I look at this, this is obviously not symmetric, okay, and it's not skewed left or right, but it's got two peaks. That's what we call bimodal. That's what we call bimodal, okay? Any questions there? And then the last one is really easy. It's just uniform, okay? So all the data is almost the exact same height. All the data is almost the exact same. Okay, so once again, just a quick refresh. Symmetric, symmetric and bell-shaped. Skewed left means tail goes left. Skewed right means tail goes right. Bimodal means two peaks and it's not symmetric, okay? Uniform means that they're all the same height or almost the same height. Are we okay with that? Okay, I know that that was quick. I'm going to give you a couple minutes. I want you to go practice them on the next page. There's one of each kind. This is how your quiz will be, but your quiz will be multiple choice. So it'll give you a graph and then it'll give you some options and you just circle the one that you think's right. Okay, let's look at the first one. What do we think? Yeah, skewed left. Follow the tail. Okay, the tail is going to the left, so that's why it's called skewed left. Perfect. The next one.
Symmetrical distribution.
Okay, is it bell-shaped?
No.
No, it's not a bell curve, but it is symmetric. Okay, we good with that?
Yeah.
What about number 4?
Skewed right.
Yeah, skewed right. We can see that we're getting a tail to the right. Okay, the data is getting lower, going to the right. Number 5.
Bell.
Yep, it's symmetric and bell-shaped. Once again, we call a bell-shaped curve a normal curve, but we'll talk about that more on day 5. The next one, this one. How do you know it's bimodal?
The 2 highest points.
The 2 highest points, good. Okay, 2 peaks. It's not symmetric. And then number 7, it is uniform. Okay, everything is almost the exact same. So that works. Any questions there? We okay with this? Okay, there's one more thing I want to talk about that just a lot of people are getting really tripped up on, okay? So I want to make sure that I'm clear. Let's say that you were making a stem and leaf graph, okay? And let's say that I gave you these numbers right here. What would be the leaves?
0. I'm at 5, 0.
Yeah, the last digits. Good, Tristan. Okay, those would be the leaves. What would be the stems here?
0.
Yeah, for these numbers, they would be 0, wouldn't they?
Mm-hmm.
And then for 10 and 12, they would obviously be 1. Are we all good with that? Okay. Cool. And you'd still need to make a key on that one. You need to make a key on any stem and leaf graph. Okay? Any questions? We feel good about this? Okay.